and welcome to my School of Hard Sums, possibly the most nerdy programme ever made. I'm going to be doing maths. The problems will be set by a maths professor. The only concession to entertainment is the presence of a comedian who will be trying to do the same problems in a much more hammer-it-out kind of fashion to see if that kind of trial and error works better than some fancy-pants, clever, elegant solution. This show is a classic battle of brains versus brawn, because when it comes to solving problems, I'm a firm believer in using maths. I love maths. It can solve pretty much any problem, from putting rockets in space or predicting the future to halving the bill on a terrible date. Tonight, I'll be using brain work and some pens to tackle 3 genuine real-world problems set by Oxford professor Marcus Asotoy. And my comedy guests will be using their brawn and whatever else is lying around to try and do the same. We've got a couple of maths students present to keep me on my toes, because none of us have seen the questions and we might not get an answer at all. But first, let's meet this week's guest, Alex Horn. Now, Alex, have you ever discovered the need or felt the need for more maths in your life?
I'm not sure about more maths. I'm currently trying to teach my eldest son how to count. He's 2.5, and at the moment he can get to 10, but he always misses out 7. And I've stopped correcting him, because I kind of think, when do you need 7? Because, you know, like in football, 6 is about that maximum.
Yeah, usually, yeah.
I think you get by with that.
Sometimes there's some tragic moments
where it goes up to 8. OK, Marcus, what's our theme this week?
The theme this week is location maths.
I'm sorry, what? It's probably my only honest reaction to that. What the hell?
Location is clearly important in many areas of life, not least in picking a house or something like that. But mathematics might be key to working out the best location for something. So a lot
numbers very important in picking your house. Numbers very important in finding out how much your neighbours pay for their house.
Yeah.
Numbers very important for going, really? OK, so location maths, what's the first of our...
OK, so to get us going, we're going to wire up some houses to some utilities. So I've got a little map here for us to work on. I've got 3 houses, OK, and you've got to find some way to wire each house up to the 3 utilities. This is gas, water and electricity. But the lines must not cross each other. So that's the rule.
Can we go anywhere with this?
Anywhere you want.
So I can go around the back?
Absolutely.
Right,
yeah, if you want to go.
okay.
It's not about the shortest distance. This is actually a problem about topology, which is not about distances. It's a study of bendy geometry, so a bit like the map of the London Underground.
Right, so 3 different utilities need to be connected to 3 different houses. Where should you lay the pipes and cables so they do not cross each other?
Shall I start?
Yeah, go for it. You're the practical man.
Of course I am.
Yeah, you don't have to think. You just draw.
I'm just going to do an
an experiment. So,
Here's an experiment, OK. So if I've done that,
yeah,
then the red... This is just a little experiment.
Yeah, this is...
Yeah.
Yeah, going.
Yeah.
So now you've got the green, so the electricity...
I see. Now I've snookered myself, haven't I?
Why is that?
Because I can get through that gap there.
Yes.
And get through that gap there.
Right, now you've got to get the electricity...
It's impossible. Can I give up?
You want to give that as your final answer?
Yeah, I'll go and get a coffee.
OK. Fine.
But this guy's got water and no electricity.
Yeah.
But if he can harness the water...
Yeah. He's going to generate his own electricity.
That's the thought, isn't it?
How are you doing, Dara?
You know, I'm probably hitting exactly the same wall.
Do you want to have another go, Alex?
Yes,
go on,
please,
see whether...
Marcus. I'm thinking it's going to be something like... This guy goes all the way around the back a few times. Oh, wow. Okay.
Well, that's beautiful. Look, you've got a whole region here to play with.
OK.
This kind of problem comes up when you're trying to lay a railway, for example. Trying to lay out this kind of network where you don't want too many crossings.
OK.
So each crossing costs you a bridge. So this sort of problem, you don't want that many crossings, so...
OK. Well, but this guy... That's not right, is it? This guy can't go anywhere. That's worse.
Yeah, that's terrible. How are the maths department doing?
The maths department are doing what we're doing, which is drawing loads of lines. Except you're not. You're doing what is known as a Möbius strip. Möbius strip, right? It's a piece of paper that has only one side. It's a shape at one side. How, in the name of Christ, that's supposed to help you in this situation?
We haven't figured that one out.
All right, OK.
Yeah.
Fine.
It seemed like a good idea.
But I'm like, it's so far outside the box. You're into some crazy country at this stage.
Yeah.
I think the key to it is trying to get all 3 of these to all 3 of these without the wires touching.
Yeah, that is the At least you've understood the problem.
Yeah, and I've got it.
Great.
Yeah, that's what we've got to do.
Yeah. Well, I think I'm going to have to call time on this in a minute, so has anybody got a solution?
No.
No. Have you got a solution?
Students?
I don't think so.
No. No.
Can anyone explain why they haven't got a solution?
I think this stuff is actually the same as if you just had one utility here, and the 3 houses there.
Oh, that's right. You can move the houses around that in bendy geometry.
There's no way you can put C to get at number 2. Because it's enclosed by the lines to number 1, number 3 from 2 of them.
If he's right, I'm going to be so angry.
Oh, really? Are you? Because,
really
in fact, the answer is that it is impossible.
Ah.
But the maths department is starting to think out of the box because they produce a new, different sort of shape, not a flat shape.
Yeah.
And in fact, this is possible to solve if the Earth was not shaped as a sphere, but was in fact shaped in the shape of a bagel, or what we call in maths world a torus, then you can actually wire these up.
So 3 different utilities to 3 different houses. That's 9 connections. On paper, it's possible to make 8 of them. Take all the gas around the outside, all the electricity around the inside, then the water can go to house 1 around the inside and house 3 around the outside. Unfortunately, the water is cut off from house 2. If you place all the buildings on what's called a torus, which you might know better as a ring donut shape, this allows you to take the water away from the houses, down to the bottom, and then back up through the hole to house number 2. Simple. But if the water company are trying to save money, a pipe to Australia and back might not be the best answer.
One thing I'm confused about is that on my street there are 3 houses, and all 3 of us have these. Does that mean...
That means you're living on a bagel-shaped Earth.
Planet.
Yeah, great, okay. They were all wrong about it being a sphere.
Yeah. Right, let's go and give us another question.
Okay.
What's the question?
This question is about laying paths and laying the least amount of paths to solve the following problem. You've got 4 cowsheds on the corners of a square field. Now, the farmer doesn't like laying paths between the cowsheds, so he's going to try and create the smallest amount of distance of path which will join up all of the cowsheds.
Okay, now these are cows who are unable to walk on soil and grass. These are presumably
exactly.
unbelievably pampered cows.
Pampered cows, that's right. So they just have to be able to get to each other, not stepping foot on the grass.
See how our claim that these are real-life problems doesn't really bear any scrutiny?
I don't think I've fully understood.
Okay, well, let's take you over.
Mess it around.
Yep, okay. Dara's going to solve it, and the maths department are solving it using abstract thought, but we've got a real fake field for you. So
I can't just do a cross? Am I completely...
Yeah, you can do a cross. That would connect up
all 4.
All 4.
That's my first instinct.
Nice.
I'm going to sort of kneel. Okay. But this is just so the cows can meet up, hook up.
Yep, exactly. Talk maths.
Hey, Marcus, does it have to be a straight line?
Straight lines are generally shortest distance. But if you've got some weird thing...
Wow,
you've got a weird thing with a circle.
I got weird things with circles. I got all sorts of things going on.
It's a thing of beauty. I mean, look, I love it.
But, there would be there's a central plaza, essentially, that they arrive into.
I can't help thinking I was right first time. But if this guy goes, like... I've saved 1. Are they all hooked up?
It's always quite good in mathematics to go for a bit of symmetry. Just a hint.
Yeah. Okay, so...
Alex, how are you finding it? What are you doing?
Frustrating. I've managed to save 1. Oh, hang on, I might have saved another one.
Yeah.
But maybe that line should be in the middle.
Okay. Shall I call time on this?
No, don't call time just yet. Wait a second.
I'll just put that right in the middle.
Funnily enough, he seems to have started drawing what you have down here. So, Dara, can you work out what the lengths are? I mean, is it genuinely shorter?
Yeah.
I mean, I finished ages ago, just so you know.
Oh, don't be a prick. Okay, we're going to try to carry on and get some nice, neat answer for this problem. We'll also, after the break, have a really big problem that we sent Alex out to actually really hammer at, which ended up with him doing this.
Where have all your clothes gone? Well, we'll find them. Is this yours?
No.
It's not, is it? No, you've stolen it. Ooh. March!
Welcome back to Dara O Briain's School of Hard Sums, the programme that pits me using brains against my fellow comic using brawn. In this case, it's Alex Horn, in a battle to find out which method is best for solving the maths problems modern life throws at us all. Hey, how are you? I'm Dara O Briain. We've been wrestling with a perplexing problem the Marcus has set, so let's see if we're making any progress. So once again, this problem is about 4 diva-like cows who won't get their hooves dirty and walk on grass to get between different cattle sheds. And a poor, poor farmer who has to lay a path to connect them all up. He doesn't want to spend a fortune on the project, so what's the shortest path the farmer can lay? You happy with that?
I'm very happy, Dara. I think I stumbled across the right answer.
And how many tiles did you end up dropping for this?
One.
One.
Yeah. So it's one better than a straight cross.
If you actually put it in and do all the trigonometry on it, right, basically you get a total length which is √3 plus 1. Now the question is that less than 2 √2? And you'd have to work that out, and I don't know it off the top of my head because I'm not that kind of person. Marcus, is that less?
Absolutely right. This solution is just slightly shorter. As you found, you managed to save one tile. So if you calculate 2 √2, it is 2.828.
2.828. And how much is this?
√3 plus 1 is 2.732.
It's hardly worth the effort.
Yeah, I was thinking that.
One tile.
I was thinking I'd probably put it down there anyway.
Yeah.
It's nice to have a tile sometimes.
However, you know how I got this? I saw him doing it. And the fact that I've got a really shiny board and I was able to write numbers about it doesn't mean I got it quicker than him. That worked.
So this is scientific collaboration because he had the great idea and you did the calculation.
The technical term is theft.
It's actually a really beautiful way to solve this, which is using bubbles, because bubbles are rather lazy. Like nature's very lazy, tries to find the most efficient solution. So I got some soap film here, some soap.
This is proper bubble mixer stuff, isn't it?
Here's a copy of our field, and here are the cow sheds. And when I put this in the bubble mixture, the soap film is going to find for me the shortest path, because bubbles are incredibly lazy. So let's put this in and see whether you were right. Okay, pull this out. Okay, do a little...
Wow, that's amazing.
There we go. Isn't that a thing of beauty?
That is gorgeous.
The best thing I've ever seen.
That is genuinely
And
stunning.
what the rules of bubbles are that bubbles meet 3 at each point at a 120-degree angle. If I put another one on here, what shape would you get? You get a hexagon.
Yeah.
And hexagons, this is the reason you see so many hexagons in nature. Things like the honeycomb. Have you ever been to the Giant's Causeway?
Yeah.
It's full of hexagons.
Stonehenge?
Not so much Stonehenge.
No, because that isn't a natural... that wasn't formed by nature, funnily enough. And look, if you only had 3 cow sheds, do you want to see the shape it would make?
Yeah.
Okay, let's pop one of the roots. Again, it's finding the most efficient way to connect them. That 120-degree angle appearing there. But actually, it's still satisfying the same rules, which were discovered by Plato, who was in fact blind when he discovered it. So you got Plato. No, not Plato. Not Plato.
Oh, sorry, not Plato. We thought you'd mispronounced Plato during all that. Like, Jenny's in the gun. He's lost this guy.
We thought he was quite clever, but you know.
Plato. Oh, right, who's Plato? And why was he...
Yeah, well, he wanted to understand the rules of how bubbles connect together.
That's very, very good. It was very, very impressive.
What if there was a hole in the middle of the field, like a donut? Would that make it easier?
Wow.
I think we're getting to him. I think we're getting to him. He's coming to the dark side.
Stuff, Now, what's our big problem? Alex, there is a big problem coming that I know we've sent you off to do some work on.
That's right. I was in charge of 5 groups of students.
My mind.
And I had to kind of gather them to one focal point. I guess Marcus might explain it better.
Exactly. This is a problem, again, a location maths problem. Yep. There's 13 students have actually taken all the clothes from one of the other students. So they had 13 pieces of clothes, and they'd scatter themselves in this city. And it's a city on a grid system. In fact, I've got a map of the city. So I've got 5 students up here at the top at the coordinate 3, 7, for example. And what you've got to do is to find which grid location is the best place to put the student who's naked at the moment, such that all the students converge on this one person in such a way that the total distance they travel is as small as possible.
So again, for you at home, different groups of students are all laid out like so. We need to find a place for them to meet up that requires the shortest total walking distance, because they are lazy students. So there's one naked guy has to go somewhere, the most efficient place for them to come to him. But importantly, you're weighted towards ones where there's more than, you know...
Oh, you're already working on it. I can see the mind ticking.
Well, I'm just saying, if, you know, because I don't know what one piece of clothing D has, but I'll definitely be able to cover more of me with the 5 pieces of clothing that A has. That, you know, so I want to get to them first.
This may have happened to you. Just the way your eyes are lighting up.
Not specifically that, but like, I mean, I've had some crazy nights.
Yeah.
You have done this, though. Were you the student, or were you just...
No, I was a livid sort of professor type.
Wonderful. Let's see this in action, ladies and gentlemen. Let's see Alex and how he attempted to solve this problem.
Hello? Hello? What happened to you? Really? You know that's not legal in this country. Still not legal. Yeah. Where have all your clothes gone? Really? You lost them in a game of strip poker? That is terribly demeaning. Well, we'll find them. You'll be all right. So, it turns out the maths dummies' clothes are with 5 different groups of students in 5 different locations, which is bad for him, but it's just like our question. It's good, isn't it? So, students, they may be the future of civilised society, but they're also pathologically lazy, aren't they? So I've got to find the best possible location for them all to meet at as quickly as possible. So we need somewhere central, so we've got the least amount of distance travel for everyone involved. And quickly, because it's cold, isn't it? It's obviously sorry, it's cold, isn't it? It's very cold. Sorry about that. Is this yours?
No.
It's not, is it?
No, you've stolen it.
Awful, very bad. I don't know if you can tell, but I am furious. Awful people. Well, here's a map. We're going to meet at a central location. A walkie-talkie.
Oh, yeah.
I'll walkie, you talkie. Finally, I've got you some distinctive clothing. This is called a hoodie. You see, it's all blue, so I'll be able to see you as a sort of team. There we go, put that on there. Let's keep you warm. Yes, please, thank you. Awful. Right, teams. I have your coordinates for the first location. They are 4, 4. I repeat, 4, 4. Ready? March! Hopefully you've left. You should be marching. So, I'm hoping they'll all get here about the same time. I think this will be a fairly average score. I'm mainly hoping they all make it.
OK, wow, they really will do anything for cash, won't they?
They were so biddable.
Really?
Nice word, isn't it?
It
Yeah,
is
they
a
were
good word, it's an
really
excellent
biddable.
word.
Yeah.
Yeah.
So my first method was just bang right in the middle.
Yeah.
I sort of pin the tail on the donkey technique.
Yeah.
So I kind of think eventually you will pin it somewhere near the correct part of the donkey, even if it's on the thigh. That'll do.
OK, well, I'm going to try to work it out, and you can watch the
watch you doing your
that I
maths.
can use.
When I looked at this, I didn't really have a clue.
It's interesting because this is, in some sense, you start off with what we're doing is turning it into numbers because you've got coordinates for each of the locations. And this was a great breakthrough made by René Descartes because he invented this system.
Can you just say the name again? 'Cause it was, yeah.
You like my René
Oh,
Descartes?
yeah. No, better the first time.
Oh, really, was it? Yeah. I mean, Cartesian geometry? Heard of that?
Not really.
Right, OK. But René Descartes realised that you could use numbers to describe geometry. If you want to say this position here, rather than try and describe it geometrically, he said, well, OK, it's 1, 2, 3, 4 steps along here, and 1, 2, 3, 4, 5, 6, 7. So he would say 4, 7. So that has changed this piece of geometry into just 2 coordinates, 2 numbers.
OK. What I might do, though, Marcus,
Yeah.
as much as I've enjoyed this, I might go and chat to the students.
Yeah, come on.
Because I just think I'll be more on their level.
OK,
Bad for
that's
them.
fine. I'll just do
Hi,
some
Dara.
maths.
Yeah.
Going for a stroll. Good for you. Hi, guys.
Hey.
That's how you talk to young people. What are you doing?
We think we've got it.
Oh,
Maybe. Yeah.
good. There we go, just
Maybe.
checking. Just,
Because I think I'm doing grand until the bit where I just add things up.
Right.
And then it goes hideously wrong.
Are you making sure that your people are walking along the kind of grid? Because you can't go through buildings.
It's an excellent point.
You were sort of crashing through private property.
My guys are doing parkour. I mean, they're free running around the city.
Oh, right.
Yeah.
Yeah, no, so actually you have to go along the line. So you
that's a pain in the arse.
Sorry about that.
so it's harder than you thought. Is it?
Yeah, thanks. Yeah, it is actually, yeah.
Just sort of do this. Just, would that help? I can do the whole thing if you want.
Yeah, no, it's all right. Don't do the whole thing. That's kind of weird.
Bye-bye.
Leave me alone.
So I think they've both not factored in the grid system.
They're still working in that field with the cows.
yeah.
That's the trouble, yeah. So, yeah, for example, if you're at A and you want to get to B, how many units do you need to travel if you stay on the grid?
Well, I'd say down and across.
Yeah, OK, so you go 1 unit, 2 units, 3 units, 4 units, 5, 6. OK. And it doesn't matter which way I go, you get the same number. 1, 2, 3, 4, 5, 6.
Because some people have to, like a knight, has to go there and then down, don't they?
Oh, yeah, that's right. And we give this a name, actually, because, you know, if you're measuring this with a ruler, as you say, you go a straight line. But this is a new sort of measuring called the taxicab metric, after the fact that on a grid system, taxis want to find the most efficient way. So in a way, you're trying to calculate for your students the shortest taxicab distance that the students will go.
I understood all of that.
Oh, there you go.
Yeah.
I have no idea if this is the right method, even. it's this messiness. It's one of these kind of...
Shit, God, what have you done?
Don't say that. I mean, is this vaguely even the right thing? That's only for one of the bloody coordinates. Oh, so I've got to dump that, and then I've got to do this, and basically, because it's not in like a field that they can all go towards, you have to take into account the fact that it's all up and up and then up and up and up, and all you have to take that into account. That makes it much more complicated as a thing to work out. About halfway through, but it's going to take pages and pages. Let's see how Alex got on instead.
I'm very nervous that no one's going to find us. Here come the yellows, marching. 2 minute 15. The greens are here. Welcome, the lonely Team D. Knees right up. Good. 4 minutes 35. The biggest groups have taken the longest time. Stop. 7 minutes 15. And the total accumulative time is 60 minutes and 20 seconds. I'm sure we can beat this. Oh dear. I've decided to move closer to one of the teams. We're actually at B's location, so we're closer to Team A with the 5 people. We're closer to Team E with 3 people. It's definitely going to be a lot quicker, in my opinion. So, march! And the greens are here! 4 seconds. Good start. 7 minutes 50. It's not looking good. What happened? You got very lost. They don't mean that. That's ironic. We're going to have to move closer to the reds this time. They're so bad at sort of functioning. I think we're going to start down here. 6-1. March! Here they come. Good reds. 55 seconds. We have some yellows. So Wilf has been 8 minutes and he's only got to go that distance. You haven't seen anyone with a purple hat on, have you? So Wilf maybe did. Well, I don't care about the blues anymore.
Just been Great Russell Street.
So he's not actually on the map, though. No. You've ruined my experiment. Over. So it's my final attempt. So this time, I'm going on gut instinct. We're going there. Teams, do not get lost. March! The greens are just there. Here they come. Listen carefully. Just hear the familiar clip-clop of the yellow team. And here we go. The red team and the blue team had a race. The reds are going to win. Here come the blues. It's just Wilf we're waiting for. I can sense him. He's made it. So that was very fast. Blew the rest out of the water, so I have an answer.
Oh, did you get an answer?
I
did.
did.
Worth the effort it took to get it?
I think
that can't
we shouldn't have
more.
used students. Students, they just kept on sort of slipping
Wandering
away.
off. You shouldn't have paid them first. That's the key thing with students. We're never paying them.
Yeah, you
They
should.
have no idea this.
I think you should have used postmen or like sheep or locusts.
It attracts them to it.
But I did get an answer.
You did get an answer.
Yeah.
Okay, Grant.
Yeah, Dara, you got an answer?
I have an answer. Let me just write it down formally
Maths
so I can
department,
present.
you've written down an answer. So
Right. Okay.
Right, so I'm going to go to the maths department first. What coordinates have you got?
We have 5-5.
They've gone for 5-5.
Alex, how about you?
As always, agreeing with the maths department. I also found 5-5. Yeah.
So Dara.
I've
you guess
gone 5-3.
Uh-oh.
Okay,
Okay.
so
Now,
Jeopardy, I like that.
There is genuinely some
in this.
jeopardy. 7 pages of work. But is it genuinely there's jeopardy here? I can't fake this. This took ages to work out. Is it 5-3? Marcus?
The answer is that you should place the student at the coordinate 5-5.
That's not, I'm not happy about that at all.
Hey.
I am not happy
So,
about
yeah, I'm not sure I should ask you how you got to the answer 5-3. Maybe I should ask the maths department. How did you focus on 5-5? Do you have loads of pages of workings or some clever idea?
Not
It's quite
really.
simple.
It's
We just worked out where the average person was of all the students. So the average X distance, the average Y distance. That told us which square we had to be in. And the,
Bish bang bomb.
Yeah.
Bish bash bosh is the actual technical term for that one.
I'm sorry, in the maths department.
Can you hold up your workings so we can at least see that there were workings there and there was some sort of method to it? That doesn't look any easier than this.
It does, Dara. Because you've done 6 enormous pieces of paper and she can hold hers up.
I just made a tiny mistake here. This was, look, I just made some tiny mistake on that. Listen, the problem with it is, if you just pick a field, if there's no walls anywhere, then it's very easy. But it's the middle of the city, so you can't do that, right?
Yeah.
Instead, you've got to work out like a far more complex thing involving, there's a graph, and the graph turns at a certain point, and I just went to the wrong one. I went to one end rather than the other.
I got
and
it, Dara.
Don't do this.
No,
you just guessed. You just picked. Your method was a crock. This was how you're supposed to do it. I am going to cry now.
That is a way
That's
to do
the
it,
gist
but there
of it.
is a much simpler way to do it.
I don't want to hear simple way. It's
There's a
7
eureka
pages, and then
moment.
last second.
You're absolutely right, but there's actually an aha moment. If you see it in the right way, this problem becomes really simple.
What
Okay,
is
let me
the
show
way?
you.
Just saying again.
Just leave me alone, right?
Bang
There's
on.
8 pages of stuff, and it was only just because of the tiny thing in there.
So actually, the question we...
I'm furious. I'm genuinely furious. I'm genuinely more fecked off than I've ever been.
And this won't help, will it?
Yeah, it doesn't.
It's so easy.
But there's actually a much simpler way to do it. Here's a kind of simpler version of this problem which reveals the trick. Because suppose I have 3 people that are living in Edinburgh and 10 people living in London. Where is the best place to arrange to meet such that the total distance everyone's travelled is as small as possible?
Well, I would have said towards the 10, but like 3/13 along.
Yeah.
You know what that is? That's so they've travelled the same amount of distance. That doesn't necessarily mean
exactly. So that's
the
the point. The best place is to meet here in London. Because if you think about it, I suppose it's 100 miles between Edinburgh and London. These 3 would have to travel 300 miles. But suppose you just moved 1 mile in this direction.
Yep.
Well, these is travelling 3 less, but these have got to go 10 more. So as soon as you move out of London, you're travelling more. So the point is to identify the person in the middle of this grid. So we can divide it up into a horizontal problem and a vertical problem, because they really don't interfere with each other.
Yeah.
There are 13 people, so you look for the 7th person, what their location is on the horizontal scale, because that's the place you all got to meet. So where is that? You've got 1 here, 5 here. The 7th person is located at this position for the horizontal direction. This is the best coordinate for the horizontal one, the one slap bang in the middle, because if you go anywhere in this direction, well, these 6 have got to move 1 distance less, but these 7 have got to move 1 more. Now we have to do the problem vertically. We'll get another coordinate. So we've got 3, 4, 5, 6. The 7th person is here. So this is the place we need to meet in the vertical direction. Meet any further here. These do 1 less. That's 6 units saved, but 7 more because they've all got to go one unit more.
That's very simple.
It's a beautiful.
Isn't it lovely? Isn't it great?
It makes me feel a bit weepy.
Yeah, can you see my 7 pages of working out?
Not
See
really.
how much would I got for rough work on that?
Work.
Yeah,
Well,
I'm genuinely shattered by that.
Yeah.
It's a really elegant solution you've got there.
It's
And
about.
do you know where you can shove it? Your elegant solution after all that.
It's a hard loser, isn't it?
I'm a really, really bad loser.
God,
but I've
and you're
actually-
taller. Well, yeah, you might think, I don't care about students and clothes, but change this problem into the location for a hospital, and this is the population of people in cities. You want to position the hospital in the best place, such that people don't have to go more distance than they have to. So this kind of problem is really important in finding the location for things like hospitals, utilities, even people delivering goods. This is what they're going to have to do.
So you shouldn't really locate hospitals, but I would.
Yeah, I
You'd
think
be the better man to do it.
Fine, back to saving lives.
So-
okay, who's the winner?
Well, I think for overall ingenuity throughout the whole of this programme in solving problems, I think I'm going to give it to Alex.
well done. Congratulations,
some great
Alex.
thinking
Wow.
there.
I mean, thank you. I was mainly pleased to get to use walkie-talkies.
Yeah,
That's all I wanted.
That's amazing. That's all you
pretty
need.
cool.
Yes, Alex, it's always a pleasure to have you on the show. You're like kryptonite for all of science. A hard-fought clash of cultures. Briain has been defeated by Braun, and so we lose. OK, we're going to give thanks to our maths department, Simi and Thomas, who did very, very well. To Alex Horn, who has been exceptional at this. But to our expert extraordinaire, Professor Marcus de Sotoy, thank you very, very much for sending the questions. We'll see you next time. Goodbye. And here's some homework for you to get to grips with. You are in the final of a game show, and there are 3 doors with prizes behind them. Behind 2 of the doors are cuddly toys, and behind the 3rd door is a shiny new car. You pick a door. The sneaky game show host now opens one of the other 2 doors and shows you a cuddly toy. To make sure you get the car, not a cuddle, should you stick with your first choice or change? If you want to see that question again, check the answer, or just cheat, have a look on the website, joindave.co.uk.
Don't get put into detention, will you? Do your homework or face the consequences. Jason Byrne is on next Monday's School of Hard Sums. Be here at 8 for the school bell. Next, have I got news for you?